All set? Great. Welcome, everybody. I guess this is the diehard crew on the last day of the conference, and you're all still here. Amazing. My name is Keith Stewart. I'm a specialist solution architect from AWS. For the last 2.5 years, I've been specializing in the analytics space, in particular EMR. But of course, nothing works in a vacuum, so EMR works with a bunch of other AWS services, and customers don't just have a problem that's just solved with EMR. They typically have other things. What I'm going to talk about today is how to leverage not just EMR, but other AWS services to be able to do predictive analytics, machine learning and predictive analytics. Just to calibrate my understanding of where people are in terms of their experience. Quick show of hands. How many use S3? It's probably the whole, okay. How many use EMR? Okay. How many use Spark on EMR? Okay. What about Spark ML on EMR? Okay. What about AWS Glue? Okay, smaller number. How about Athena? Oh, wow, surprising number. Okay. What about QuickSight? Okay, smaller number. All right. So I'm going to try, assuming we have enough time, to talk about the various components, why they're advantageous for your predictive analytics needs. And hopefully, if we have time at the end, I'll be able to get through a demo and try to show you how you can quickly go from raw data to training a model, making predictions, querying results with Athena, and maybe even displaying things with QuickSight. All right, so let's see here. Okay, so what we're going to cover, predictive analytics, of course. We're going to define it, what is it, why it's important these days as time goes on. How can you do it at scale? We're all drowning in data. Companies nowadays are dealing with petabytes, multiple petabytes, sometimes even more. I think, was it yesterday, there was a company that used our snowmobile because they have hundreds of petabytes. So we're definitely in the petabyte age. So how do you deal with that scale? Also, how do you move quickly in the analytics space? Prior to a number of the services that we've offered, it was a very painstaking and slow process to be able to do predictive analytics. So we'll talk about how you move quickly. If we break this question down into its components, we can ask, how do you do a data lake with S3 and AWS Glue? So a data lake, of course, is going to give you that capacity to manage petabytes of data. Then we're going to ask the question, how do you train a predictive machine learning model in a distributed fashion? In other words, with a cluster of servers, as opposed to your laptop, right? And so specifically focusing on EMR, Apache Spark and Spark ML, and then we'll use the Zeppelin notebook to be able to quickly put together the code. And then how do you do distributed SQL queries over potentially petabytes of data, right? And that, of course, you can use Athena for. And then how do you visualize it? QuickSight. So, and then at the end, we'll do, depending on how much time we have, we'll try to get as quickly through all the things we talk about through a demo. Okay, so what is predictive analytics? Why is it important? So just a few definitions. Analytics is really the discovery, interpretation, and communication of meaningful patterns in data. Predictive analytics goes one step further. It brings in a bunch of rigorous statistical techniques from areas like predictive modeling, machine learning, data mining, and you use that to analyze the current base of data as well as historical data and learn patterns within that data to be able to make predictions or classifications, or what we call inferences. And you can see examples of what customers are trying to do with things like, questions like which customers are likely to be the most profitable, right? That's an important question. How much revenue should I expect from this particular customer, right? Which customers are likely to churn, right? If we're not doing a great job keeping customers happy, there's a risk we could lose them. So what's the probability for certain customers? Among all the customers we have, which are likely to respond to our next big offer? And then what's the probability that a specific customer will respond to a specific offer, right? Then you can look at the product or service offerings that you have, and you can leverage predictive analytics to ask questions like, what products should we offer or develop, right? What items are likely to be purchased together? It's often called basket analysis. And then there's your operations, your business operations. You'd like to understand things like, are the metrics for our particular service, are they nominal, or is there something anomalous about them, right? And you'd like to know that as soon as possible. And then if you're running equipment, what's the probability that it's likely to fail within the near future? Okay, so things are changing in the business landscape and in terms of data processing, and predictive analytics is becoming increasingly vital. Okay? For the last umpteen years, companies have been accumulating lots and lots of data, a lot of transactional data. Now there's social media, there's IoT devices generating data. So companies have been accumulating data for a long time, and they're sitting on all this data and then wondering, how can they get value out of that? How can they get insights? We've built, with the technologies I've talked about, AWS has built big data technologies, or analytics as we call them, to address the data management and the processing of that data. But there's some real pressure now to be faster than your competitor, to be able to take advantage of your data and insights from that data to better address treat customers, give them a more optimal experience, to run things more efficiently, preventative maintenance on equipment that might die. And so there's an increasing pressure to do that. And so you want to leverage all this accumulated data and do classifications and so on. Okay? And there's a desire to evolve now. If we take a look at the history of the predictive of analytics, we used to be satisfied with doing quarterly reports, monthly reports, maybe even weekly reports, but that's a rear view mirror perspective on your data. You're trying to answer questions, what happened in the past, right? That has value, but it's not as important as what's going to happen next, right? So companies are now trying to understand in real time through alerts what's happening right now on our website, right? What's happening right now with a specific customer? Are they happy? Are they sad? And equipment, etc. You want to know instantaneously right now what's happening. But even that's not getting good enough for companies. A lot of them want to be able to make forecasts and move into the predictive analytics space. So it's clearly an evolution of what companies expect now from their data, and you want to be able to take advantage of the tools that can do that. Okay, so how do you do this at scale, right? We talked about petabyte and more data. How do you do it with agility? We like to think of the big data problem space in these kind of abstract phases. Of course, there's storage. You've got to have your data in some place in order to be able to make analyses and make predictions from it. So storage has to be addressed, and there's lots of different solutions for that. You want to be able to process it, do ETL, transform the data, clean it up, and that turns out to be a significant percentage of the time. And then you want to be able to do the machine learning and inferencing, and then finally be able to visualize results so that you can quickly identify situations. Those abstract components have solutions out there, lots of open source solutions. We have lots of customers running these open source solutions on EC2, for example. But what we offer is managed services, which is aiming to relieve the heavy lifting that customers have. So instead of taking the kind of the Wild West of the open source technologies, trying to harness that, deploy it, maintain it, et cetera, we provide systems that are fully managed. You just launch them, take advantage of them, and you let us worry about babysitting the servers that are behind those. And we even include now, of course, a number of serverless applications. So managed services are a great way to gain agility, because you're going to save yourself a lot of headaches and a lot of time by having systems that are automated in their deployment and configuration. Okay, so if we take those abstract components, collection or ingestion, storage, processing or analysis, and then consuming or visualizing the data, we have a lot of solutions. And you'll see both open source and managed services here. I'm obviously not going to go through all these, but we have a lot of choices, and there are different trade-offs with the different options. So if you're going to collect and store the data, there are differences in terms of latency, in terms of the durability, and so on, and of course cost. And so if you're dealing with data with different temperatures, as we show on here, temperatures meaning the velocity of the data, how quickly it needs to be captured and dealt with, or whether it's cold, and so that can often determine the pricing and the choice of technology that you'll use. Okay, so we're not going to cover all those. I'm going to focus on these components here: Amazon S3, AWS Glue, which are the storage and ETL parts of the solution, Spark and Spark ML on EMR, and Athena. I'm not going to talk about AI, but that's a solution that's out there as well, and we have QuickSight as well. So why S3? So S3 is an excellent solution for a data lake. It doesn't care what the data is, whether it's a single byte or a 5 terabyte video file. So it will hold any kind of data. It's scalable and elastic. If any of you have run Hadoop clusters on-prem, you know what a pain it is to have to stay ahead of your storage requirements. You have to have enough capacity through, say, HDFS to give you 3x replication of your data. If you leverage the decoupling of storage and compute that EMR provides, using S3 as the back-end persistence, that will take care of your storage. You don't need to be on top of how fast your data is growing, because S3 is there to grow elastically to accommodate that data. 11 nines of durability, so you're protecting your data when you put it on S3. And this is the bandwidth is an interesting consideration. There's no upper limit on the aggregate inbound bandwidth going into S3. The only limit is the number of hosts and processes and threads that are simultaneously talking to S3. So if you need a higher bandwidth, you need more data going in a shorter period of time, have more hosts and processes and threads sending that data to S3. All of that bandwidth will be accommodated. There's no upper limit on that. Extremely low cost, 2.3 cents per gigabyte month, or 23 bucks per terabyte. And virtually all the AWS services take advantage of S3. It's a foundational service, rock solid. It's ideal for a data lake. And this just summarizes the benefits, including things like performance, and it's integrated with all the other AWS services. And it's easy to use. AWS Glue. So Glue came out, I guess it was earlier this year. And Glue is aiming to reduce the heavy lifting involved in the ETL and processing and schematizing of your data, taking semi-structured or unstructured data and turning it into structure, superimposing a structure on it that you can then work with in terms of queries and processing. But a really key part, and we'll take a look closely at this, the really key part is the data catalog. So the Glue data catalog is a service that will crawl your data. You simply indicate which data sources, S3 buckets, for example, you tell it where to crawl, and what it'll do is either on a recurring basis or on a triggered basis when you launch it, it will crawl through your data. Think of CSV, Parquet, etc., and then it will generate the schema for you. So you don't need to do data exploration to figure out what kind of schema to superimpose on your data. The data catalog will do that, and it's pretty quick. So once your data lands on S3, you launch Glue on it, which is a fully managed service, and it will turn that data into something that you can then very quickly start to query and work with in a structured way. It'll also do transformation, ETL. We won't get into that today. As I said, you can do it on a recurring basis with a job scheduler. It runs on top of Apache Spark, so it's very fast and integrated with a bunch of other data stores. And you can work with the data through a JDBC connection. Right, so you discover it. So it manages the metadata. So those of you familiar with Hadoop and EMR, it will create the metadata entries corresponding to your unstructured and semi-structured data, the Hive metastore. And then that Hive metastore becomes available for a bunch of other systems like EMR and Spark and Presto and so on. So that's just a screenshot, but we'll get into the demo on this. We've extended it now so you can search the metadata to find your data sources. So a lot of us will be accumulating multiple different types of data, and we may tag those in different ways. But the Glue data catalog allows you to find those through searching. We talked about the connections, classifications. So when it's schematizing the data, it's looking at the entries within the columns. Okay, if it's like a CSV or JSON or whatever, it'll scan the data, the sample of data in the columns, and from that automatically infer what's the appropriate data type for that column, and it'll add that to the schema. Right? And it manages versions. Okay, so it populates the Hive using Hive DDL, and you can also do bulk imports. And we talked about crawlers. Right, so the crawlers, they have built-in classifiers to crawl through things like JSON and XML and Parquet, etc. But you can also design your own classifiers. So if you have some oddball data format, you can do that, and then it'll take advantage of those and extracts the schemas. Okay, and you'll be able to contribute to the open source any type of crawlers that you think would be generally useful. Okay, it'll work with partitions. So if you're familiar with Hadoop and familiar with how EMR can partition the data on something like HDFS or S3, the particularly time series data and so on, Glue will automatically pick those up as well. Right, so you can run them on schedule. You can have it triggered by schema changes, and it's serverless. There's no server for you to spin up and babysit. Amazon EMR, I think a good number of you are familiar with that. This is our scalable Hadoop as a service. That's something of a misnomer, though. It's really more of a massively parallel processing platform, MPP platform. It runs a variety of MPP frameworks, not just Hadoop. It does Spark. It also does Presto and a bunch of other MPP frameworks, HBase as well. It's easy to use. It's a managed service. You focus in terms of the cluster and how big you want it to be. You don't worry about individual servers. It's on demand, so you can spin up a cluster anytime and you can shut it down anytime, and you cease to pay the hourly. I guess now we're charging by the second, so you don't you can use it for less than an hour and save money compared to what it was previously, because we're rounding it down to the nearest second. And there's different ways to pay for things. You can have reserved instances based on a commitment to use certain types for the year. Spot pricing, so it can automatically take advantage of the spot pool, right? The instances that are not yet allocated to customers. And it works with a variety of file systems. Most of our customers, however, are using S3 because of the economics and all the other benefits of S3 and the high performance. And now, recently with 5.8, since 5.8, we're now up to 5.10 of EMR. It works with the AWS Glue data catalog, and we'll walk through an example of that with EMR. And of course, end-to-end security. Very popular, lots and lots of customers. This is just a small sample of the big name customers that are using EMR on a daily basis. Some of them with multiple petabytes of data. Spark ML is very powerful. We, Spark ML, Apache Spark ML includes a whole host of different models that you can train with. In our demo, we'll walk through an example with decision trees. But it includes capabilities of implementing what's called a pipeline, where you can take data that's represented as data frames, and you can queue up or link together a bunch of transformations on those data frames, and manage that as a first-order entity. You could persist the pipeline and then retrieve it in some other application and immediately use whatever model was trained with that pipeline. Okay. Decision trees. Everybody know what decision trees are? This is a simple example showing, you have a bunch of predictors or attributes, and then you'll have a target attribute that you're trying to predict based on some inherent pattern in those other attributes. And essentially what it's doing is building a decision tree in memory, a branching structure where there's criteria that have to be checked as you work through the tree to categorize or make predictions on the attribute. Another example, this one's a kind of a financial one, bank loan write-offs. So you can look at balances, the age of the person, whether they're employed or not, and then make predictions as to whether there'll be a bank write-off. And that it makes the point down here that you take features together as vectors. So most or nearly all machine learning works with numerical vectors. You can train on categorical data and string data, but those strings have to be first converted into indexes, into numerical values, and then bundled together to create your feature that will inform the model. Okay, QuickSight, fast business analytics. Wide variety of data visualizations, works with a wide variety of data sources. You can perform ad hoc analyses, and supports hundreds of thousands of users. We have an enterprise version, so you can give your whole company access to QuickSight. And we've expanded the visualizations And this allows, because it runs in the cloud where your data is and where your computational results are, it's very fast at taking that data. You're not having to download data or move it around. QuickSight will work with it immediately because both of them are in the cloud. Right, that's just a summary of integrated, cloud native, super fast and easy, cost effective. I think it's down to like $9 per seat per month, so very inexpensive. It's not a Tableau or a MicroStrategy or Looker. It's not meant for power users that like to really play around with data. What it is for the average user to be able to easily take data that they can see in their account in the cloud and very quickly put together visualizations and be able to share those with their colleagues, all without being a data scientist. Okay. One of the capabilities underlying QuickSight is an engine called SPICE, which is super fast, parallel, in-memory computational engine, I think. That's why we shorten it to SPICE. But essentially, it's a data cube, if you want to think of it that way, running in memory. Okay, so data that you want to analyze, even on S3, which is persisted data, can be pulled into SPICE, and then you can interrogate that in a variety of ways, generating a variety of different visualizations, one after the other, without any delay. Okay, so let's do a demo here. All right, so just to set things up, we're gonna pretend we're a car company called Lux Cars, right? And we're going to be bringing a fancy, expensive car to market. We'll call it the Luxmobile. But we want to do some intelligent marketing. We want to leverage predictive analytics to understand who is going to be the best type of customer for this. Ideally, we want customers that we think have higher than average incomes. They have high enough incomes to afford our car. We don't want to waste our time advertising to people who are unlikely to buy it, right? So we want to focus the marketing on wealthy people, and we're going to take advantage of some demographic data where we have some characteristics for the geography that we want to target. Things like the age of the individual, the number of years of education, whatever degree they had, what industries they work in, all those kind of demographic data. We have those, but we don't know their incomes, right? So what we want to be able to do is infer their income based on those other attributes. Not infer in terms of precise values, but in a kind of binary fashion. Now, the data set I'm using in this demo is an old data set, so the cutoff for wealthy, I guess, is 50K. So it's an old data set, but it serves our purposes to illustrate. Right, so we need to predict salary, or the salary category, income category, from the demographic data. So how are we going to approach this? Okay, so we're going to take U.S. Census income data and move that into the cloud. So we'll see that process. We want to schematize the data. So the data is in file format, it's in CSV format, but we want to schematize it. We want to superimpose a tabular structure on it that we can then leverage to do things like machine learning. So we want to train a Spark machine learning model on the data. And then we want to do batch prediction, given a bunch of individuals, anonymized individuals, of course, without income data. We want to be able to use our trained model to figure out what category are they in, right? And this step I actually didn't get to in the demo, so we'll skip that. The idea was that if you combined income predictions with state or zip codes, for example, you you had an idea of the number of individuals that are in the upper category for that zip code, you could compute something like a wealth density, right? You could look to see what kind of above average incomes per zip code per square mile would be available, and then that could drive your marketing, right? And then we want to visualize predictions, okay? And then share the results with our marketing director at Luxcars, okay? So we're going to take data that's sitting out on the U.S. out on a website. It actually isn't it's the U.S. Census data, but it's at the UCI machine learning repository. Well, we're going to in AWS, we're going to spin up an EC2 instance, download that data, unpack it, get it into an S3 bucket, okay? And then we're going to run Glue on it to schematize it, to be able to create entries in the Glue data catalog in the Metastore that we can then take advantage of. We're going to have an Amazon EMR cluster running Zeppelin Notebook and Spark Machine Learning. And so then we're going to take that data, the training portion, and train a decision tree using Spark ML. And then we're going to take the customers for which we don't know incomes and make predictions and store those. We'll query them with Athena. And then, depending on time, we'll get to QuickSight and visualize them. Okay, and then one of the things you can do with QuickSight is build these stories, so you can put together a particular perspective on the data. It's web-based, so you can share that with colleagues, such as our marketing director. Okay, so let's build this. You probably can't read that, right? Tell me when that gets readable for people at the back. Is that good? Too large? No? Okay. So I won't bother spinning up an EC2 instance. I'm sure you guys have done that, but I have one already running. So let me connect to that. Actually, this text you probably can't read, right? Okay. And that needs to be larger too. It's readable initially on my screen, but when it attaches to the high definition projector, it scrunches it down. Okay, so, all right, so with EC2, you need to SSH into it with your key, so we're going to do that. Assuming I've got network connectivity. All right. Oh, that might have been the tunnel. Okay. Oh, looks like I may already. Okay, I'm already logged in on this terminal here. Okay, so what we would do is use wget to pull the data down. I've already done that, and I've got the data in, let's see, census income test. Let's see. Let's see. All right, so we would, some of you, or most of you perhaps are already familiar with this, but we could create a bucket using our CLI. So we say AWS S3, make bucket. We give it a S3 URI, and we'll call it test bucket. Okay. Oh, probably because I need to. that. Okay, so that was successful. And then we could do AWS, S3 CP, and we'll take the census income data and put that into our bucket. That is test bucket. And we'll call it, we could call it training. Okay, so that data is up on, in an S3 bucket. I've actually got another bucket with better data, but so we'll move on to now, so that's in S3. Now what we want to do is run Glue and schematize that data. So we'll go AWS Glue, and let's see. Actually, I want to delete that one because we're going to recreate that as part of the demo. Okay, and census training, where is it now? CSV, too many. Oh, here it is. Okay, so if we took that data and ran Glue on it, this is what we would have. I'll launch a crawler to do another one, just so you see that process. Okay, that's not the one. So we add a crawler. We can call it incomes data CR04. I think I've got other ones there. You indicate you're going to use S3. You could use other data sources, and we have our data in S3, so we're going to find that, and we'll go to where's the one I want to do? Incomes ML, right? So there, that one, and then we have this. Let's see. Okay, and then we're going to go, we're not going to grab any other data, we're going to stick with that. Of course, for permissions, you need to use a role that gives Glue permission to work with that data. We're going to have it run on demand. We'll create a new database. Let's see, what do we, oops. Okay, and that. So these are all the specs we gave it. We say finish, and then we get this prompt that says was created to run on demand. You want to run it now? So we do that. Now that'll complete fairly quickly, but I've got a complete data set already crawled by Glue, and what that does when Glue is done, it creates the database or reuses a database that we already had. And the one I'm going to use, this is small, is, where is it? Incomes, this one here. So that database, and then we have a bunch of tables in here, and we're gonna take a look at this one. So this had, you can see it was able to schematize. It was able to look at the comma-separated data, the header, and to be able to work out the appropriate schema for that data sitting on S3 located at incomes ML CSV2. Okay. So now we'll go to the machine learning. So now I could spin up an EMR cluster, but it would take 10 minutes, and I don't want to waste your time with that. So what I've done is already spun up a cluster with Spark. And as for those that have used EMR, you know it's very straightforward. If you want Spark or Presto or HBase, there's just checkboxes in the web UI that you click on, and when it spins up, it'll have those applications. If you're launching EMR from the command line with the AWS CLI, there are just parameters that you can use to specify what set of applications you want running. Anyways, I previously spun up this cluster with Spark, and and Zeppelin. So this Zeppelin notebook you're seeing, you probably can't read that. This Zeppelin notebook is running on the master node in the EMR cluster. And within that notebook, we're running Spark. You can see the directive there, Spark. So we're going to run a bunch of Spark code in this notebook. And although the notebook is running on the master node, it is distributing the processing across all the nodes in the cluster. And I think this is like a 10-node cluster or something like that. But anyways, if I clear the output, let's see. Clear output. Yep. So we start over. Okay, so now I just have code. And what I'm doing here is asking Spark to look at the data catalog, this metastore that Glue created, and give us, and set the current database that Spark is going to use from Glue to that incomes 3 DB. And then it's going to show us a list of tables in that database. So I execute this cell, and we get the list of tables, right? This is going to perform a sequence. Is that readable? Is it readable? Or let me make it a little bit larger. So this is going to create a data frame by running Spark SQL across that entry in the Glue data catalog, that table. In this case, it's called CSV2. And it's going to pull out certain fields. Now this data set, the census data set is very large. It's got like over 40 attributes. We're only concerned with a few of them. We're going to look at age, the working class attribute, and the education achieved, whether the person has relationships, that kind of thing that comes, and their income category, of course. So we're going to create this data frame, which puts the data in memory. So this will execute, and it tells us the schema here, the schema of the data frame. There's more data, more attributes. The blue bar was indicating progress, and then we ask it here to give us a sampling of 10, show us 10 rows from that. Okay, so we've got age, working class, education. You can see some of them are string values, some of them are numeric values, and then we have the income category, less than or equal to 50K or greater than 50K. All right, so we've now got the data in memory. Now we're going to ask, we're going to start to do the training, and actually I think there's supposed to be, yeah, there's some text there. We're going to convert these fields. As I said earlier, machine learning typically requires numerical data, and it has to take string data, categorical data, and convert those into numbers, and then build vectors to represent the numerical features, and that's what the models get trained on. Now you can always, once you have predictions, you can go back to what the original labels were, and we'll see that in another cell coming up. But this code, if you can read that, we're going to convert the string attribute, the working class string attribute. We're going to create a work class indexer. And essentially what that does is we take the data frame that we created earlier, okay, or when we execute, it'll create. And then it's going to convert the values into a set of indices based on the range of values that are available. And then it'll set that into a separate column, separate field called work class index. Similarly for the education, we're going to take that string and convert that into a numeric index, relationship, and then the income indexer as well. Then we use something called a vector assembler, which takes a bunch of these attributes and that are now numerical and builds a vector, assembles a vector from those, and calls that set of vectors features. That's what's going to be used in the training. Here we're simply dividing up the data between training and test data. Here we're instantiating a decision tree classifier where we tell it what is what column to call the predictions, right? Or the set of columns. and then what columns that we've already declared, in other words, the features that will be used to train the model, right? And then here is where we build a label converter which can go backwards from index to the corresponding label, string label. And then we build a pipeline. So SparkML version, I think it was 2, came out with the pipeline architecture where you can put all these things together and then manage that as a first order entity, persisting it, retrieving it in a different application, etc. So we basically string together stages shown here, including the assembler, including the income indexer, the label, the decision tree, and then the label converter. And essentially all we're doing is saying there's a series of transformations on this data frame that we've pulled out of the database, a series of transformations that result in additional columns for things like predictions, right? And as well as the numeric features. And then at the end, the last column gives us the conversion back to the original label. So this is a relatively small data set, so when I execute this, it should go pretty quickly. It's just telling us what it's doing. The blue bar indicates it's still running. You've got a % up here. Those of you who have done SparkML know all of this, but it sounded like the audience was a significant number of people that hadn't used SparkML. So, okay, so it's almost done here. It's letting us know the various things it's instantiated and declared, and yeah, and so it's finished. All right, so the next cell should be text. Yeah, fit the decision tree classifier. So all we've done so far is queued up the data frames for the eventual training of the model. We've declared the pipeline, but we haven't yet trained the model. That's where the next step is. And this is where we take the pipeline that we declared and we ask it to fit the pipeline to the training data. So essentially that runs the training data through that pipeline, through all the various stages, through the various transformations, and results in a trained model. Right? So that goes fairly quickly as well. Okay, so it told us it down here, it instantiated the model. And then this step, we're getting near the end here. This step is going to now make some predictions on a different set of data. This is where we're going to infer the income of samples for which we did not have income data. So here we're taking the model that's now been trained. We're asking it to do a transformation, in other words, a prediction on the test data. And that results in a data frame called Preds. And then this one, we're pulling out certain fields because there's a lot of intermediate vectors and stuff that just kind of pollute the screen. So I'm selectively pulling out interesting and useful attributes, and you can see them declared there. And we're going to show 10 samples. And then we're going to write this data back out to S3 using the Hive table called predicted incomes. Okay, so we'll run that, and it's fairly quick too. Okay, so we got our 10 samples. This is these are the predicted label here. Okay, the blue bar says it's still running. Okay, that finished, and no errors, so the data went to S3, right, and this one, yeah, we'll skip that one. So now we've, just to sum up what we did with EMR and SparkML, we took that schematized data that Glue created for us in the data catalog. It's essentially a meta store. Spark was able to query that data, pulling out particular fields. It took those, rendered them in numerical fashion, trained a decision tree, took that decision tree classifier model, and then fed it previously unseen samples and got predictions for what the income would be. And then those results were sent back to S3 using the database that we connected to at the beginning. Okay, so let's now look at Athena. And maybe it's worth showing the, just to recap. Oops, where'd it go? This one right here. Just to remind everybody. Okay, so we're now done all these steps. We've got data sitting in S3, and we're going to now query it with Athena. So I'll go back here, type in Athena. There we go. Okay, and Athena is a fully managed service. There's no servers, no cluster to spin up and run. And what we're going to do is take our CSV table here with various attributes and write a query. We can do, select, this is the original raw data from CSV2, limit, let's do 100. Okay, so here's the original data that we pulled off the internet, put into S3, ran through Glue, and you can see it's structured, and we've got 100 samples there. We can now, you can see, remember I deleted that predicted incomes table previously before we started. We now have a predicted incomes table showing up thanks to Spark sending that back to the Metastore. And we've got these attributes, including the predicted label. And for this, we can, let's run a new query. And what do we call it? Predicted incomes. Limit 100. Okay. So there's the data there, and if we scroll over, you can see the predicted label. Okay. So we can interact with the data. We could run additional queries on it, etc. And now, QuickSight. Let's see. Services. QuickSight. There we go. Okay, and all dashboards. Let me see. Make that a little larger. We'll just go to a convenient data source. And so here we, the data was on S3. It's pulled into Spice, which you can see over here. Probably a little hard to see. We can very easily generate these graphics and then share those with, we can create a storyboard. Oh, I guess we have a storyboard already, do we? Let's see, visualize. You could change the graphs as well. Okay, and let's see. Export. Trying to remember how you share it with somebody. But it's via a story, so you can put together your selection of the various visualizations. They're already on the web, and then you can share those with other users, including our marketing director. So with that, that's the demo. As you can see, things move pretty quickly with the services, most of them being managed services. That's the way to go if you want agility. And if you want elasticity and scalability, Make sure you're using things like S3 and scalable clusters like EMR. I forgot to mention that it can dynamically change. You can auto-scale EMR. So if you've got more data to crunch, you can set thresholds and criteria for that automatic expansion. So a lot of tools. It takes time to play with them and get familiar with them. Think about scenarios like this hypothetical one where you're trying to leverage existing data, train a model, and then be able to predict on new data that you haven't previously seen and leverage that in your business. So with that, I'll take questions, and we'll do that now. Okay. Mm-hmm. You don't program Glue. Well, okay, so Glue, you can create classifiers. Right now we support Python. It's a good question. I don't know if we would move to Scala or not. Python is very popular for doing ETL and transformations and classifications. But that's a good suggestion. We can. Mm-hmm. I don't, but I think the slides, I can probably update the slides with a link online for people to follow. Yeah, and the Scala code for doing the machine learning, I can share that as well. And these data sets we can share. They're U.S. Census data, so. Yep. Search what? Yeah, if you search on the identifier for our, yep.
Two questions. I didn't see in your code where you defined the model.
Oh yeah, it was in the Scala code in SparkML. Yeah, it instantiated a decision tree classifier. Yeah, decision trees are very popular because they work with both categorical data and numerical data. And they're pretty robust and high performance. So they're. Yeah, you could have numerical predictions. In this case, we had binary, greater than or less than 50K, but you could have a numerical output as well. Yeah, but there are other probably better ones like linear regression that would be better for that. Oh, in SageMaker?
I have one in Amazon Machine Learning, but that's black box.
Yeah. Well, Spark definitely has more than one linear regression model, and SageMaker, if it doesn't have it today, it will very soon have it. Yep.
And follow-up question.
Yep.
So you had this thing that generated stories.
Yeah, the QuickSight. Yep.
Why? I don't get. If you had QuickSight, why do you need
Oh yeah. Go ahead.
Okay, so the second question was, if you are using QuickSight, why would you need something like Athena and the Spice?
Well, so why would you need QuickSight why would you need Athena if you've got QuickSight? So they're apples and oranges. So QuickSight is for visualization. You wouldn't do high performance predictions. You wouldn't do queries, complex queries on it. It's more for there's like data scale limits and that kind of thing. Like it depends on the size of your Spice engine. You have to, when you sign up, you have to decide how much RAM you want your Spice engines to have, things like that.
Your demo was at scale for the small number of rows and small.
Yeah, this was a small set of data. Yeah. Well, Athena is for doing complex SQL queries, like ANSI SQL, with nested subqueries and that kind of thing. QuickSight is really just for rendering as graphs and charts. Well, what you can do is run Athena on some data to create a specialized view, pulling out certain columns. a materialized view, and then you could create a data store from the results of Athena. And then you can go to QuickSight and point to that data source and do graphical rendering of the data. So you can use the two of them. Right. Well, so yeah, QuickSight can interface with it can interface with Athena tables, but also Redshift, and so you can tap into other data sources. I used S3 because that's the one with the best value proposition in my mind. You know, the scale, elasticity, the low cost, and yeah. Yeah, but it doesn't have to be S3. It could be an RDS database as well. Yep.
So I have a question about Glue.
Mm-hmm.
So what kind of type format that Glue is? In this case, you use
CSV, yeah.
like JSON format or?
JSON, XML, Parquet, ORC. Trying to think if there's anything else.
So anything like just column row?
Pretty much Hadoop, standard Hadoop formats.
And then you just schematize. That's all it does.
Yeah, it looks at your data. It replaces the heavy lifting that you would normally do. If you had your raw data, you would go in and look at it, try to figure out, what is the appropriate data type for this column or field, and what should my table look like, and then you would create the metastore entry manually, right? What this is doing is saving you from all that. You put your data on S3, crawl it, and then it creates the metastore entry for you.
But doesn't the Spark automatically does that for you? Like, let's say you import the JSON format with Spark.
Yeah, Spark can query CSV data as well, but what you're trying to do with Glue is to create a metastore entry. You're trying to figure out, you're trying to schematize the data so that it can be used in a variety of ways. It could be used for Presto. It could be used for loading into a relational database. The metastore is persistent. So even if your EMR cluster goes away, that data is still on S3, and there's a tabular interpretation of it in the data catalog. So it lives beyond the cluster. The Spark version, the schema interpretation only lasts as long as Spark is running, right? Right.
So if you want to work with a different S3 location
Yep.
later, that's going to have the same format, then you can just edit the table,
Change the location.
change the
Yep.
location, and use
For the external table. Yep.
Yeah.
Yep.
For the Spark ML, one thing you mentioned black box for Amazon machine learning. Like, I did a demo of that the other day. I was wondering, for Spark ML, it creates this model, this decision tree. It's like it's picking, it's picking, and it has some confidence, but because it picks certain things like less than 50 or more than 50. Like, can you look? Is there a way to look at the model and see like what things it's weighting to come up with that prediction, or some way? 'Cause
Right.
The thing I get is that the people that I work with are not that interested in me predicting. They're interested in that.
They want to know how you predict it. Right.
Programs or policies to
Yeah.
affect those outcomes.
Yep. So the question is, how can you understand in the decision tree? Can you understand how it arrives at its predictions? Yes, that's in fact one of the real benefits of decision trees. Some of these other more exotic machine learning models are fairly opaque. And it's hard. Certainly, things like deep learning models. You've got a bunch of neurons and weights between them, and the sheer number is just astronomical. So decision trees have that advantage, is that you can actually see what's the criteria to go from one node to down one branch and then a sub branch and so on. You can actually see that criteria.
But it's not baked into the output. You have to kind of run a different command again.
Yeah, you'd have to interrogate the decision, the model that's been trained. Yeah.
That was Scala that you wrote to do that. Can you do other languages?
Yeah, Python, yeah, Spark. Spark does a lot of languages. Spark, there's Python, which is super popular. Scala, you could do Java if you're a masochist maybe, but R, Spark R. What else is there? I think,
Kind of all out, like you do all that through that Zeppelin kind of IDE. And is that multi-user? Like, can you have multiple people in that Zeppelin thing at the same time doing different work?
no, there are actually better notebooks for like managing individuals. So things like Jupyter notebooks are better, where you can actually have separate user accounts. Actually, that's not true, because if you look at Jupyter is getting very popular. Yeah, I can't think and type at the same time. So Zeppelin is it's good for things like Spark and so on. Jupyter is largely used for things like Python. I guess you can use Jupyter for Scala as well. It depends on what interpreters have been plugged in. I think even Presto, you can run Presto through Jupyter. Yeah. Yeah, here it is. So there is actually some oh yeah, here, credential. I don't know what that does actually. Nothing's popping up. But apparently there's I don't know why it's not. Maybe I lost my connection. Oh.
I'll do some research on that. Thank you for the.
Yeah, well, hopefully you got a sense of kind of the breadth of functionality and how you can go fairly quickly. Once you get comfortable with how things work, you can very quickly zip through these things and go from raw data to predictions to visualizing results. Okay, go ahead.
So I just wanted to make a comment that this demo should be much, much improved by modernizing the data set.
Yeah.
The government public cloud summit, I met my corresponding number at the U.S. Census Bureau, who has worked with an outside firm to take the data from the American Continual Survey.
Mm-hmm.
The TUMS data, which you justifiably did not want to parse, and put it into a graph format that can be queried dynamically online.
Right.
Since he presented that, and since they have some pretty beautiful data that allows you to user interfaces that allows you to run reporting stuff in a very Athena-like way.
Mm-hmm.
It would be worthwhile to update the demo and use more.
Yeah. I mean, I didn't have a lot of time to put this together, so had I had more time, I would have researched better data sources. I mean, a lot of the value you get is a function of the size and quality of the data set, and what kind of attributes are present. So, but good point. We do have an AWS public data sets site where you can get big data sets on S3 that are world readable. So from your own account, from your own AWS account, you can work with those data sets, which are already in the cloud. You're not paying for that storage. Yeah. Oh, okay. Yep. Yeah. Yeah, we have things like the New York City taxi cab data set, which is massive. That's like a petabyte, or a billion records anyways. I'm sorry, I think you raised your hand first.
Let's say you have your data lake in S3,
Mm-hmm.
you digitize your data. Is there any support for column level security?
Well, so data in S3 by default, without you doing anything, is secured. The only way it becomes unsecured is if you deliberately make it world readable, or you decide to make it readable by others. Yeah, now, let's see. Athena. Yeah, Athena can work with encrypted fields and columns, I believe, yes, if I remember correctly.
That's what the data store
Yes. Yep.
Maybe to provide more details, how to train the model in a distributed way using the EMR.
More details than I showed. Well, what I did was distributed training. Right, so Spark, the way Spark works is it essentially partitions the data, spreads the data across the cluster, okay, and then it pushes copies of the code to the data. So each partition is working with a different slice of the data. Now there's replication within the cluster, at least in on-prem. With EMR, we're taking advantage of S3's durability, but the data gets partitioned, and so you get these nodes with multiple cores, each running a copy of the code, processing their own local data, right? But then there's what they call shuffling, where you bring related data together for final roll-ups and aggregations and results that way. That's a very simplified explanation of how Spark works. Yep. Well, there was no deep learning here. This was traditional decision tree. Yep. So deep learning, you would probably, well, the best way to do deep learning would be on SageMaker, because that's a managed service. It takes a lot of the headache away. It's managing multiple containers, ECS containers, for managed training. So you have your data, and you simply make a call with your data, indicating what kind of training you want. The service does the training for you. There's nothing for you to spin up and manage that way. And then you get a trained model coming back, and then you can deploy that into production. That's the best way to do deep learning. You could also take deep learning AMIs, deep learning AMI, and deploy it on multiple EC2s or ECS containers. You could do it that way as well. You can put load balancers in front of it. That's more work, but it's still virtualized servers, so you're not having to buy hardware to do your deep learning. Yep. All right, I think we probably need to wrap it up. One last question. I'm sorry. Compare Athena and S3 Select. That's a new announcement. Oh, S3 Select. Yeah, that's brand new. You heard it the first time I did. So it's, yeah, what it's doing essentially is pruning this search tree, I guess. It's pushing predicates down to the S3 level, so that instead of S3 returning all the data for something else to filter and work through and decide on, you push predicates down to the S3 level, and then S3 only returns what matches the predicates. So it cuts down dramatically on the amount of I/O. Presto does push down of predicates as well, yeah, but this is at the S3 level, S3 Select. Well, yeah, you can definitely get a performance boost with S3 Select, yeah, because it's operating at it's avoiding unnecessary data I/O. It's only sending back the data that actually matches the predicate, right? So, okay. The ML.
Yeah, the Spark Lib, we are running that on EMR, right? The one that you showed. Can we not run the ML code on Glue itself and not have EMR storage?
So Glue does ETL. It transforms the data, and it schematizes the data, puts an entry in the metastore. You don't do machine learning on Glue, right? You need EMR to take advantage of Spark ML, right? So Glue isn't so much compute as it is ETL and schematizing the data. So it's not designed for machine learning. Okay.
Yeah. For Glue, so it only
Mm-hmm. You have to understand with big data, you don't want to be moving or copying data. So what is the schematizing, what it's doing is defining an interpretation of the data that's already persisted. You're not going to move that data, you're not going to copy it anywhere. You're going to leave it where it is, create a metastore entry that superimposes a definition or defines an interpretation so that then something like Hive or Pig and Spark and Presto can then query that data by essentially scanning the data, but it's leveraging that metastore table definition for the data. I'm sorry, say that again.
No actual transformation.
No, no. So Glue has two functions. It has the ETL capability, and we didn't go through that. That's where you can define how you want data transformed, cleaned up, perhaps. But the key thing that I showed was the data catalog, where it crawls your data on S3. It could be other data sources, but it crawls your data on S3 and figures out what that metastore tabular interpretation should be, and creates an entry in the metastore to be used by EMR and other things, Athena. It is a Hive data store essentially, yeah, but it's automating the creation of the entries in the Hive metastore. So, okay, all right, thanks everybody.